own Milky Way, astronomers have found something staggering: a colossal wall of galaxies stretching over 1.4 billion light years, hidden in the cosmic shadow near the South Pole in the universe. Its sheer matter at the motion of countless galaxies, ours included. It is a relic of a violent cosmic collision, or a struggle holding the universe in a delicate balance. Before the end of this video, we will uncover what it is, how we found it, and why it may rewrite our map of the cosmos. The South Pole Wall is one of the largest structures ever detected in the observable universe, a hidden reach of galaxies so vast it spans nearly a tenth of the cosmic horizon. Only in the past few years has astronomers peered the blinding star fields of the Milky Way to reveal its form. In this episode, we will journey through three pillars of discovery: how the worlds were mapped, what it might mean for cosmic flow and hidden mass, and the figure debates it had ignited among the cosmologists. Stay till the end, and you will see why this structure challenged our most trusted models of the universe. Before we can grasp the enormity of the South Pole Wall, we need to understand where it sits in the cosmic landscape. Astronomers divide the universe into the vast web of the filaments, chains of the galaxy born by gravity, and immersed voids, regions almost empty of matter. Our own Milky Way lies within the Laniakea supercluster, a gravitational dome that includes all the titans like the subtly concentration. The South Pole Wall lies just beyond the edge of Laniakea, concealed behind the thick plane of the Milky Way disk. This region, called the zone of avoidance, a notorious difficulty to study because the dust and gas obscure visible light. To map it, scientists rely on radio waves and redshift measurements, tracing how galaxies move relative to the cosmic expansion, a motion known as peculiar velocity. What they found is staggering: a contiguous arc of galaxies and stars stretching over 1.4 billion light years, with enough mass to subtly influence the motion of thousands of galaxies. Yet, because of its location, much of it remained hidden from topical telescopes. The question is not just what the South Pole Wall is, but why is it, and whether it formed through gradual cosmic evolution of some extraordinary ancient event. In 2020, a lead team by Daniel Pomerode used data from the Cosmic Flow 3 survey to prove one of the most elusive regions of the sky, the zone of avoidance. By measuring the redshift of more than 17,000 galaxies and correcting for the Milky Way own motion, they created a three-dimensional map of cosmic structures in unprecedented detail, hidden within the radio and infrared signal. That's what enormous feature: a curving wall of galaxies arching across the southern sky, extending over 1.4 billion years. The detection wasn't a single snapshot moment, but the culmination of years of benchmarking work. Cosmic Flow 3 had been gathering distance and velocities using techniques like Topley-Fisher relation, which links a galaxy brightness and rotation speed. This data revealed that many galaxies in the region were not moving poorly with cosmic expansion. They were being subtly drawn toward a massive, unseen structure. 1. Redshift mapping. Every galaxy light is triggered by universe expansion, but subtler deviation, peculiar velocities, reveal gravitational tugs. By precisely measuring this redshift, astronomers could detect motions hinting at the massive hidden structure. 2. Distant calibration. Using the top-line feature relation, they linked a galaxy's rotation speed to its intrinsic brightness. Comparing this with obscure brightness gave accurate distance, essential for mapping in 3 dimensions. Multi-wavelength penetration. Optical telescopes were used in the dusty zone of avoidance. Instead, radio observation traced cool hydrogen gas, while infrared surveys like 2MAS8 and WISE pierced the dust to reveal accurate galaxies. 4. Velocity field reconstruction. By combining distance and redshift, the team built a velocity flow model showing how thousands of galaxies move relative to cosmic expansion, allowing them to infer the South Pole world gravitational influence. Each step it not only confirmed the world's existence, but also hinted that its cosmos revolving other cosmic gems like the slow and great world that far more hidden from human eyes. When started against other titanic cosmic struggle, the slower Great War, the Hercules Corona Polaris Great War, or the subtly concentration, the South Pole War holds its own in scale but stand apart of secrecy. The South Pole War, by contrast, laid masked behind the Milky Way's dense disk, its discovery delayed for decades simply because of its vantage point. One common objection is that the world might be an illusion created by patchy data in the zone of avoidance, perhaps just several unconnected clusters that happen to line up, but velocity flow reconstructions undermine that idea. The coherent gravitational pull across vast distance strongly suggests a continuous mass. The revelation in the South Pole War reset more than just our cosmic maps. It shapes our understanding of how gravity scrubs the universe. By adding this massive, hidden reach to the web of known structure, astronomers can refine models of cosmic flow, improving prediction of the motion of galaxies, including our own. The master because the rationale of those models fits into a fundamental measurement, such as the Hubble constant, thus underpins our estimate of the universe age and expansion rate. In the near term, upcoming surveys like the various European Observatory Legacy Survey of Space and Time will extend our reach into the zone of avoidance, testing whether the South Pole world had unseen extension. If confirmed, its sheer scale could offer a laboratory for studying dark matter distribution and the roles of cosmic voids in the shaping galaxy evolution. Skeptics point out that our view of the South Pole world is still incomplete. Large worms remain concealed behind the Milky Way dust, and without direct optional confirmation, Part of the structure could be misinterpreted. Some astronomers caution that the velocity flow methods used to detect it rely on assumptions about galaxy distance and motions that may introduce subtle bias. Other limitation is cosmic variation, the statistical fact that in a universe that late, rare structures will occasionally appear bigger or denser than expected. It's impossible that what we see at a single causal world could, with more precise data, fragment into smaller filaments connected only loosely. Imagine standing on the cliff edge, staring across the ocean you thought you knew, only to glimpse the shadowy outline of an entire continent beyond the horizon. That's what the South Pole World is to our cosmic map, a vast landmass of the sea of galaxies, revealed only when we dare to look through the dusk. What else could be hiding in the blind spot of our universe? As new instruments peer in the veil, we can find that the cosmos is even less uniform and far more dramatic than we dare to imagine. Question for viewer: if the South Pole War turned out to be just one part of an even larger structure, what do you think it will reveal about the universe past? A slow growth from the gravity,